In this video, I'm going to look at an R script that simulates the so-called Monty Hall problem. So it goes from a game show in which there are three choices behind curtains or doors, and in the statement of the problem, there are two of them are prizes you don't want, a goat, and one of them is a car, and they're all the doors are closed. You pick the contestant picks one, and then the next step is for one of the other doors to be shown to be a goat. And then, so maybe in the picture shown, maybe they chose one. And so three happened to be a goat. So you are showing that one of the non-choices was a goat. And then the question is, should you, and they give you the opportunity to change your choice. And the question is, should you? And people's usual intuition says, well, it's 50-50. So um, maybe they should, doesn't matter. But that's not the correct answer. That's just their intuition. And it turns out that it is beneficial to make the change. And I guess one more point is that this game show is still sort of out there in the modern version. They don't usually talk about goats, but they I think they call it a zonk. But so it's still, let's make a deal, sort of, and this sort of problem is still sort of out there going on. Okay, so here's my little R simulation. N is my number of samples, and then I have a set of choices, and I just called them G1, G2, and C. So I have two, goat one, goat two, and the car. Um, and I just have, I'm just going to make this big long list. And I set up a for loop that goes through my number of samples. So I made a sequence from one, in this case, to 100. And I'm taking I through that. And I'm using R's sample. I'm sampling from the choices, this vector up here. I'm choosing three, so I'm choosing all of them, and I am not allowing any replacements. So goat one, goat two, and car always have to appear. And then I had sort of an empty list. I created here an 8, and then I'm using the length of the Monty Hall list so far, uh, and adding 1 to it. So that is giving me a sort of a new index, and I'm setting it equal to these choices, so those three, some arrangement of goat 1, goat 2, and car that I just added. And then sort of while I was in this first loop, I added another, I'll call it column, to my list here, this index 4. And that is a sample of 1, 2, 3. The integers 1, 2, 3. I'm picking 1. The replacement doesn't really matter. I'm only picking 1. But and so that is the user's choice. So at this stage, up to this stage here, let me run that, and let's look at Monte Carlo over here. So at this stage, we haven't been shown anything yet. They haven't shown me a goat, but here's in sample 1, it was curtain door 1 was goat 2, and door 2 was goat 1, and door 3 was the car, and the user chose door 2, which was goat number 1. And And that's how it goes at this stage. Okay. And I could probably do this all in one loop, but I wanted to sort of break it down. Okay. So now here is my next loop, same sequence 1 to n over all the samples. And I have a lot of print statements so I could see down in the console what was going on. But I want to show a door, and I want to show, and I always show a door, not the contestant's choice. Probably end up referring to it as the user, not the user's choice, and not the car. So I start with the show choices. The possible choices of which door to show are 1, 2, 3. So I just made a sequence from 1 to 3. And then I'm going to find where the car is. So I am looking for the C in this thing. So match is going to find me the location, the index. And I'm looking, I is which sample I'm in. So for a given sample, for the ith sample, I'm looking for the C, I'm finding its location. So that's where the car is, and I'm not going to show that. And I'm also not going to show the user. So I'm getting rid of the user's choice and the car. So in some circumstances, I'm getting rid of two choices. So there's only one thing I can show you. And other times, if the person has chosen the car, then there are still two things that the two different goats that might be shown. So this line 23 is taking, it's a little ugly looking, but I am taking the show choices 1, 2, 3, and then this exclamation is a not. And so I'm looking for the choices uh, sort of in or not in. So eventually there's this not. So, but I'm looking for choices that are in, and then I'm making a vector of the car location and the user's choice. So I make a vector with the location of the car and the user's choice, and then I'm looking for the choices. So I'm eliminating the choices. So I'm picking out the choices. Show choices equals show choices that are not in this list of the car location and the user's choice. Okay, that's a very cumbersome line, but it works. So we are getting rid of this is the door. This is what we can show, the door or curtain that we can show. And again, there may be only one or there may be two, depending on if the user shows the car or didn't shows the car. And I'm printing out just to show the process as we go to make sure that things made sense. And then I need to pick one of the doors to show. At first, I tried to use sample again, and that wasn't working for me. I tried to, of the remaining choices, choose one, and that was wreaking havoc. I didn't investigate this thoroughly, but my quick guess is that the method sample is like overloaded, that there's more than one version of sample. And when I was having my choices, when there was only one thing in my set of choices, I was kind of like throwing it off and trying to, and it ended up using one of the other versions of sample. And so this just wasn't working for me. So what I did instead was I used runif. Runif1 is a random number between 0 and 1. I multiplied it by the length of my choices, which is again either 1 or 2. So then I end up with a random number between either 0 and 1 or 0 and 2, depending on my situation. I take the floor of that, so I'm getting just the integer part. So if there's only one choice, then length of that is 1, run is some random number between 0 and 1 times that, and then when I take the floor, it's always 0, and then I added 1 to it and got a 1. If there were two choices, then I was getting a random number between 0 and 1, but multiplying it by 2. So that was a random number between 0 and 2. And if I took the floor, I either got a 0 or a 1. And then when I added the 1, I got a 1 or a 2. So these are the possible indices of, uh, of the door I can show. And then here I am picking which door I can show. Sometimes there's no choice, sometimes there is a choice. And I made that my fifth column. So when we look at everything, I'm going to show what door was shown to the user, to the contestant. And now I have a column where I remember the user's original choice, but I also want to now say, what if they switch? So I'm going to do sort of add that into my scenario. And there is really, if you decide to switch, there is no real choice in what you switch to. But just because I had done that above, I used sort of some similar uh, code. So I started with the switch choices of 1, 2, 3. I might switch to 1, 2, 3, but I'm playing that same game here. And what do I eliminate in the switch? I eliminate what was shown. I'm not going to pick what was shown. It was a goat, and I know it was a goat, and I don't want the goat. So I'm not going to pick what was shown to me, 5, and I'm not, if I'm switching, I'm not picking my original choice, which was 4. Suddenly now I'm the user. But so I'm eliminating the user, and I'm eliminating what was shown. And so there's only one choice left, and I'm putting that in my column 6. So let me run it that far. So let me clear out that, clear out that, clear out that. And now I'm going to run uh, sort of I now have 2 loops, the original setting up of the situation, and then the switching, the showing and the switching. So here we are, and I'm going to look over. And I put these all in one big list so that I could sort of do this sort of analysis here. So let's look at sample 1. There was goat 1, the car, goat 2. The user chose 1. Then I'm not going to show them their choice. I'm not going to show them the car, so I'm forced to show them 3. And if they switch, they're not going to choose their original choice of 1, and they're not going to choose what I showed them in 3, so they must choose 2. Let's do another 1 or 2. Here was another situation. They chose 3 this time. Then I was forced to show them 1, and if they're switching, they have to switch to 2. It's the only difference is when they actually get it. So their original choice was right. So here's go 2, car, go 1. They chose the car. They had a choice of 1 or 3. I showed them 1. And if they switched, then they must have switched to 3. So this is just I have their original choice in position 4, and I have what was shown, and I have if they switch, what they switched to. So I'm not now I want to finally do the statistics. So back here, one final loop. And again, I think all these loops could be combined, but I'm just trying to break it down so it's sort of it can be followed. And now I have sums uh, for winning or losing, and I could probably get rid of some of these for loops and do some fancy R stuff. But this was good enough for me anyway. Kind of an old-fashioned programmer. I have a sum. Original win is if the original choice wins, and switch win is the number of wins. If you switch and I loop over, the original and the switch numbers ended up as characters. and uh, and I want to use those as indices, so I had to cast them as integers. So that's this as integer. And so the original choice or the original index was Monty Hall I, the ith sample, column 4, and then I'm casting that as an integer. I'm doing the same thing for the switch. And I could be more efficient that either they sort of won or they didn't, or they kept their choice or they didn't. But I just did, if the original choice was a C for a car, I added 1 to the win. And if the switch choice was a C, I added 1 to the switch. So now I'll run the whole thing. And this, clear it all. So we're not making sure we don't have any old results. Run it. And so here we have again that situation where we can sort of see one by one what was going on, and you can maybe look at that and sort of see if you had the intuition that it didn't matter. You can sort of maybe build up a new intuition by looking at case after case and seeing like how many times, how often making the switch made you a winner. Okay. Um, but I want to look at, what do I want to look at? The wins and the losses. So here is, I ran again 100 samples. The original one for this sample of 100, 28 times, and the switching 172 times. So this is going to be within some fluctuation from sample to sample. Um, the original choice should win about a third of the time. There were 3 choices, you pick one, and the showing doesn't affect, if you keep your choice, doesn't affect how often you win. So you win about a third of the time. If you switch, then basically it comes out that if you were winning, you will now lose, and if you were losing, you will now win. So if you only originally won a third of the time, if you switch, you should win 2/3 of the time. And that's roughly borne out here. I could up my sample size to 1,000, 10,000 or something, or run it again. That's easier for me just to run it again. And now we see 3961, 3664, 2080, 3268. So we see that it's always, in the ballpark of 1/3 original choice wins and 2/3 of switching wins. And that's what all the results of the Monty Hall say. That it doesn't matter, tuition is wrong, that it is worth your while just statistically to make the change. And I just wanted to, there are lots of people who have all their different explanations of it. I just wanted to do it as sort of playing around with an R program. So that's all I have. Thanks for your attention.